Hello, precious plastic community. We are all having troubles with the plastic monsters. So today we are building the Blastic IoT Scale Pro version. So let's quickly take a look at the materials. We have a tool instead for starting. You will need an Allen key or this bit holding screwdriver. Two 3D printed housings you can find in the download kit, or the already sold version for one of them from the Arduino original R4 Wi-Fi. That's this is the similar to the end result we will get, and but we will have the up-to-date board on it. Then we have some bolts, M3 bolts, 8 millimeters, 30 millimeters. Just one M3 nut for them you will need. That is also optional. This one is another optional, that is an SD card holder, just to organize your SD card as needed. Well, now with one hand I cannot extract them. These are M12 nuts, but flat nuts that are thinner than the regular ones, that will go with these. A hook, better style hook that is in the bomb, it is this one. Now we reuse this one that is leftover, and a washer, and an eye bolt is also our M12. Then we have an already assembled plastic board scale with the right orientation on the screw terminal, and there is a video to build that. Our Arduino R4 Wi-Fi, and we will use this load cell sensor. These are alternatives. I'm showing you that because I'm starting to talk about the build, starting with the build now. This one is the one we will use in this build, but in the BOM you will be directed to ones with this kind of lid that also has screws in it, and we will use these screws and also the threaded holes they have underneath them. If it happens, as it happened to me, to this one that I scrapped from the BOM list for your purchase, I broke the screws when I was trying the first time to extract them, or in this case I have no leads at all. In this unfortunate situation, you can still go and have a successful build by making your hole with appropriate drill and taking your care, lubricating, but this is the true hole, and that will make for this. This is as a difference from the regular ones, not threaded hole, so we will go through it with a full length bolt instead of the shorter one that simply lock in the thread. This one will go all the way through and be locked with his nut on the other side. So let me prepare your point of view and let's start this build. So we have the centerpiece. This is like the main structural component, and also the load cell that will get the measurement by the electrical signals that feel the distortion of these thinner places when the load is applied. And we have the sensor, and now as the first thing we will screw one long screw in this case to secure the Arduino R4 Wi-Fi base to the S-load sensor, S-type load sensor. Let's start in doing that. This particular build, I will help myself also with the appropriate Allen key or screwdriver with bit. This particular build, we will immediately start building also the back. The normal build, you can also do that in a later stage. So I'm threading the bolt through the hole, and now I want to take the 3D printed I just got to choose the right orientation, that is this one, with the wave-like structure that is by the side of the outgoing wire. So I will place this hole I'm gonna choose, and in this hole I will place a nut. This kind of build is mandatory because we need to do the S shape of the load sensor to deform freely. So the whole enclosure is designed to hold on just 1 or 2 points on one side only of the sensor, to allow it to freely deform, and so giving a proper indication. Okay, we started to lock it, and now we can simply snap the Arduino in its case. If it is the original, it would be a little bit easier. Then, if you're, it is kinda optional, but you can also screw it down to the case. I'm gonna do that. So, give a little example of the method. And since it's 3D printed, it's a little bit harder to screw down, because you have got also to form the thread in the plastic as you're screwing. But with a little patience, you can get the result you need. Okay. I'm gonna also add another one, so I have got a fully locked this one is a little bit hard. Okay, starting catching up, and now it is easier. Okay. I forgot, I would have liked to make this passage first, that is placing the main eye bolt into the load sensor body, because without the 3D printed parts I have better access. Now I got to fiddle a little bit, so if you want you can do it in an earlier stage. Okay, all the eye bolt will lock even without the bolt, the nut, but the nut will allow you to have better control when you need to lock everything in the position that you want. Otherwise you are stuck with the orientation you will get at first. Okay, this one I'm gonna leave it out, but I'm gonna secure it in this place with the flat bolt, flat nut. Inserting the hook like a bolt, like that, into the threaded hole from the sensor, and now working a little bit with the nut to choose my orientation. I can also use some thread lock on the nut to make it really perform as I want. Okay, I want it to be perpendicular to the body of the sensor, so I will lock it by hand. You can also use some pliers if you want for this. And now it is locked. Okay, I'm starting to take shape, and I will go on with the build of the electronic part. And this one is, I've already placed the one long 330mm screw. I've got to insert in the from the upper 3D printed part, from the housing of the Arduino 4 to the 3D printed part that is called battery holder. You will see why in a second. We call them that way. Okay, there. I will take 3 more screws. I will take also the IoT Blastic Scale board and place it on top of the Arduino using the pins. That holds it in place really well. I cannot snap it outside, but we'll secure further with some screws. And as before, I've got to thread my way into the 3D printed parts. You can also prepare the 3D printed part before putting in place by screwing the bolt before starting the build. Then you will find yourself with a easier certain task, the one that I'm doing right now. But you can also go like I'm doing now on the first try. Okay, let's drag this down. And then here I'm just using the final placement of the bolt as a reference. I'm placing all the bolts first, then I will secure a little more than later, just to give me some room for eventually needed adjustments. Screwing the upper right down. Then is the right one. It's a little bit hard. Okay. This one is a little bit harder to do, and you may want to take your micro SD card mount out of the way before screwing down the bolt. You can easily do that somehow, a little bit pulling, but there is not very much room for that. Okay, so let's go on. And this is like the pattern for mounting the bolt. I really recommend to screw, before doing this, to screw the sensor cable, which I have not done. I'm doing that right now. I will speed up the whole process because this is the wrong way, as good old Stanley Olio did. Always show the wrong way first, just for educational purposes, and then let's do the proper way this time. So before placing the electronic board, let's screw the sensor. You've got color labeling up there. The one that does not got any color we will not consider, because it's only shielding from the cable that we are not using. And then we'll just change the bit, in my case, to screw down the wires in the appropriate slot. So the red one is on the left. When you've turned upside down the board, let's open a little bit the new unused. Let's make a little bit of more space to do this work. Also, I'll try to get a little bit more light. Okay, and then you screw. As you go, you can also look into the hole and check the mechanism if you are not sure how to loosen and lock it. When you see it moving, you can quite easily get a hang of its working. If it's too long, it's the exposed part of the kinda succeeded in threading it. If it's too long, don't mind cutting it simply. So we are done with the black one. checking. And then going on from the left to right, red, black, white cable. Okay. Okay. Sorry. And then go on with the last one, which is the green. If you should have any this one I didn't got right, so I will redo it. If you get any issues with the interference from maybe electrically polluted environment, like some kind of laboratories are, you can go on and take the remaining naked portion of the cable car and solder it to this hole, or place a different configuration from the screw terminals. In this case we will simply cut it away because we don't need that, and it will be configured as a floating shield that will do just good. So we've done the linking from the sensor to the electrical board, its amplifier, and all the control EC, the main brain for the scale, will be connected after the screwing in this way. It is a convenient way, using pins, and then we will just redo the work of securing the electronic board to the 3D printed power battery holder. Oh, let's use this M30 bolt in the upper right hole from the electronic board, and this other M3 30mm bolt in the down right hole of the electronic board to the appropriate. This one is a little bit fiddly, but just with a little bit of pulling you can get the right placement of it, and then thread the plastic with a little bit of pressure, down pressure. When the head of the bolt needs to pass the SD card holder, it will be a little bit a point in which you can lift up to get this passing, as I've just done, and then you have okay, the build is nearly completed. We just need some little screwing down as you please. You can adjust or secure everything. It is basically done, and it looks like that. And to power it on, you got to place this last component, that is the power bank. We are now taking from another scale, and we will also use some Velcro tape to hold it in place, which is my preferred option, much preferred than the simple scotch I'm using here, simple card tape. And this is quite an inexpensive power bank, like 10 euros. Just check your bomb to choose, or use one you have already have. And this is placed here against the holder, which has slots for the nylon holding tape to secure it and make it this one fully auto-secured device. Now I got to find this piece of equipment. Oh, where I did place it? Okay, sorry I do not have it on hand now because we just moved all our lab to an exhibition. By the way, we won Makers of Merit at the European Maker Fair, but the result here is kind of sick, so excuse me for the extra footage. Just to complete the video, I will use some tape anyway, just to show you how it ends, how it looks, how it holds. Of course, the nylon method is much better than this, but you have got it all in your bomb. Excuse me for not showing now, but this is the result you can get. Okay. This is just as an example. Then, when I have secured everything, I can just plug I recommend to use a short USB-C cable, and maybe turning it a little bit into the case, just to have a shorter wire, even shorter. Then you can plug the Arduino USB-C part with the power bank and the system will power up, and the scale can also start waiting because this scale has been already configured. Again, I can get a weight, I can take the weight to upload it, then choose the plastic type by touching the buttons, let's say polypropylene. This one will not have Wi-Fi, so it will give me Wi-Fi error. Okay, I think. And this is the build. We will be left with all this that I recommend to tape also with the nylon removable here, just to have a compact device. You can also take another choice and just cut it short, and just like in this previous version as I've been done, then you can equally screw as this one the wires from the cell, and so you will be left without all this extra cable. I'm leaving it there for some reason. You could also be tempted, or it could be necessary to use the electronic part separated from the sensor, or this way is the shortest way to build, but you can refine it if you want. Just be careful to recalibrate the scale after you have cut your wire short, if you do that, because the measurement will change with the length of the cable chain. So we have done this Blastic IoT Scale build, and I want to say you goodbye. Have a happy build. Ciao.